So in example 5, let's graph another one with all those steps, just because we need more practice at it. So this time our quadratic function is f of x equals 4x squared minus 2x plus 1. They're asking us the same exact steps as the previous example. So we're going to start off by finding the vertex. Again, we'll do our negative b over 2a. So that would be a negative of a negative 2 all over 2 times 4. So we'll end up with a positive, but 2 over 8 is going to give us a positive 1/4, which is not as nice as the last example. So we now know in terms of the vertex that the x coordinate is 1/4. So in order to find the y coordinate, we're going to find f of 1/4. So that's 4 times 1/4 squared minus 2 times 1/4 plus 1. In general, make sure that you give it back as a fraction if it starts with a fraction, which we are. So we're going to let the calculator do the grunt of the work. You can go ahead and figure it out. It should come out to be 3/4. 3/4. Great, wonderful. Then it also wants that axis of symmetry. So our axis of symmetry again is always x equal. And it's x equal to the x coordinate of the vertex. So right smack through the middle of this thing is our reflection line, basically. And they also want to know whether it's concave up or concave down. This time we have a positive out in front. So we know it's concave up. So it opens up, which means it has a minimum, which comes important in a few minutes. So in our next example. Okay, they're asking us to find the x-intercepts. This is part B on that problem. So the x-intercepts, we're going to find those by setting the function equal to 0 and solving it. This time it does not factor. There are no factors of 4 that are going to add to 2. So we've had to use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So it becomes 2 plus or minus that negative 2 squared under the radical minus 4 times 1. Well, if you take that one step further, that's 4 minus 16. That's a negative 12 all over 8. And that negative on that inside of the radical tells me that these are not real, which tells me there are no x-intercepts. And actually, we didn't need to do all that. We could have thought about this first, but I wanted an example of what to do when it didn't factor in your notes. So please note that this particular vertex is in quadrant 1 and it opens up. So if we're in quadrant 1 and we're opening up, there's no way it's going to cross the x-axis, which is what that says. So we knew that. But again, if it doesn't factor and it does cross the x-axis, you're going to come in and basically use the quadratic form. The y-intercept is really easy. We're just going to find f of 0. So if this is 0 and this is 0, the first two terms are 0, and you end up at 1. So the y-intercept is at. Okay, so that gives us everything we need in order to be able to graph it. Okay, now there's a grid sitting on your handout. I'm going to make my grid a little bit larger, just so because those fractions. Wow, I need another marker already. So I'm going to use 1 and 1. So 1/4 would be here, 3/4 would be about here. So this is 1, this is 1. And we know that its x-intercept is at 1. So we're going to go over here. And because I like to have a nice symmetrical way of graphing this thing, the x-intercepts would work, but I don't have any. So what we're going to do is recognize that this distance from here to here is a 1/4. So that means over on this side, I have another point that's a 1/4. So this is really at a 1/2, 1. So that would give me the width that I need in order to get the pretty picture drawing. So there it is. Much harder on your grid that you have on the handout, but there it is. Now we can answer the rest of the questions. So the domain is automatically all real numbers. The range is the bottom of the graph. Well, the bottom of our graph is at that 3/4. And it goes off towards infinity. Where is it increasing and decreasing? Well, it decreases first. So we'll do the decreasing side first. That would be from negative infinity all the way to 1/4. It is going downhill from negative infinity to 1/4. And then at 1/4, it starts going back up a little bit. So 1/4 infinity. Yay! They also want to know when the function is either greater than 0 or less than 0. So f of x greater than 0, well, that would be everywhere. Again, this is asking me where is it above the x-axis? This graph is above the x-axis everywhere. So from negative infinity to infinity. And f of x less than 0 is nowhere. So we'll say no solution. So it doesn't exist. Yeah. So there's an example of one that does not have x-intercepts, and we found that 2 different ways. So that's kind of nice. Okay, our next example, example 6, tells us to determine without graphing whether the given quadratic function has a maximum or a minimum, and then find that value. So not graph it. Let's just use algebra to find it. Well, we can do that. So example 6, a quadratic function we're given this time is f of x is equal to 2x squared plus 12x minus 3. Okay, well, this is our a, and because a is greater than, positive, greater than 0, we know that it opens up. It is concave up. And because it's concave up, it looks like this. So this means we have a minimum. And you don't really need to write any of that out, but just to show you where that thought process is coming from. That 2 is positive, therefore it opens up and it has a minimum. So in order to find the minimum, we're going to go do the negative b over 2. So that's negative 12 all over 2 times 2. That's negative 12 divided by 4 is negative 3. That is the x coordinate of that minimum. What they're asking for, though, is the y coordinate. So f of negative 3 would be 2 times negative 3 squared plus 12 times negative 3 minus 3. Again, be really careful. Square first. So this is 2 times 9 minus 36 minus 3. So that's 18 minus 36 minus 3. That's a negative 18 minus 3 is a negative 21. Okay, so the minimum value is this negative 21. So the only reason I needed this negative 3 was to get to that answer. So that's our minimum value, is the negative 21. Okay, and then finally, in our last example for this section, we're going to do that go backwards problem, which I really like. What this means is they're going to give me information about the graph and ask me for the equation of the parabola. So, example 7 says, determine the quadratic function whose graph is given. Well, in order to write a quadratic function, we need 2 things. Points. We need 2 specific points. So we need a vertex and we need another point. So a second point. But they have to give me the vertex. Working it from any other set of points is not going to work for us because we're not going to get the correct width to it or the correct height to it. So you have to have the vertex. So from our picture, we can see that the vertex, the top of this parabola is at negative 3, 2. And because I need a second point, I'm looking to see where there's a nice point. Well, those x-intercepts are not nice points, but the y-intercept is. So we also have the second point, which is going to be 0, negative 4. And between those 2 things, we can write the equation. So we're going to go for the vertex one. So f of x is equal to a times x minus h squared plus k. So h is that negative 3 and k is that 2. So we now know that we have a times x minus a minus 3. So notice as I put it back in the parentheses, its sign gets changed, plus 2. Now what we have to do is find a. And we're going to use the second point. Use find a, use the second point. And that's why you need that second point in order to find a. And again, a tells us all kinds of wonderful things, the width and the up and the down. So we have to find a. So we're going to set negative 4, that's the y coordinate of that second point, is equal to a. X is 0 at that point, plus 3 squared plus 2. Thus negative 4 is equal to 3 squared is 9a plus 2. So 9a would be equal to a negative 6. And way down here on the bottom, a is a negative 6 over 9. We'll reduce that and give a negative 3 halves. So now we have a. Sorry, that was a little sloppy. I'll come back up over here. So to answer the question, our quadratic function is f of x is equal to -3/2. That's the a we just found. And then we already had the x plus 3 quantity squared. And then the plus 2. And there it is. There's the quadratic function that fits that graph. And you'll notice that it does back up the fact that it's opening down. So notice that it is a little wide, and that's because 3/2, the absolute value is bigger than 1. So fantastic. Those are your quadratic functions. Yay!